A very important theorem in calculus is the intermediate value theorem, and it's a good illustration of why the idea of continuity is important. So let me read this theorem, then I'll try to explain it, and then I'll show an example and where we can apply it. So it says here, suppose that f is continuous on a closed interval a to b, and let n be any number between f of a and f of b, where f of a doesn't equal f of b. Then there exists a number c in between the open interval a to b, such that f of c equals n. Now, if you're new to mathematics and reading mathematical language, this feels like a lot of words. So I'm going to try to break it down as easily as I can. And if you have any questions, just let me know. Okay, so let's get a picture. I think the picture will help us with this. So here I have my x and y axis. And I'm going to pick a couple of points along the x-axis, A and B. And then let's go ahead and pick a couple of points along the y-axis that we'll call f of A and f of B. So what that means is that my function f passes through these points, a f of a and b f of b. Now, this function is continuous. So what that means is that I have to connect this point a f of a and this point b f of b with the function that can be drawn with one pen stroke and doesn't overlap or anything weird like that. So it may go down, it may go up, but eventually it's going to end up in those two places. Okay, and I have to be a little careful. It looks like I went straight up right in here, but it's not exactly straight up. Alright, now what we say next then is that there is a number n somewhere between f of a and f of b. So you can pick anything in between there. How about I pick this guy right here? So there's my n. And it says, okay, if you find that n, then you can find a c somewhere in between a and b. So c is down here, such that f of c equals n. So if you notice, I can come over to my graph here, drop a line down here, and so I pick this point c, and that c is special in that the function takes on the value n at x equals c. And that's all the intermediate value theorem is saying. It's saying that if you go anywhere along between f of a and f of b, you can find a c somewhere between a and b that hits that function value that you're interested in. Let's see, like this. Okay, so you can always hit it, and the only time you're guaranteed that that's going to happen is if you have a continuous function. Okay, now let me show you an example where this is useful, and hopefully this makes sense. Okay, so here's my question. Is there a number exactly one more than its cube? Okay, so this sounds like an algebra question, doesn't sound like calculus, but what we're asking is there a number x such that if I add 1 to x, I get x cubed? Does this equation have a solution? Okay, so the way I'm going to do this is I'm going to set it equal to 0. So I have x cubed minus x minus 1. And now I'm going to let f of x, some function, be defined as x cubed minus x minus 1. Okay, now this is a type of function that we know. This is a polynomial. And something I know about polynomials is that they're continuous everywhere. So it's continuous on negative infinity to positive infinity. That means the intermediate value applies to it. Okay, and in particular, what I want to know is, does this function ever hit 0? Okay, so that's the question I'm asking here. Does f of x equal 0 for some x? Alright, and I'm going to say it does. And how do I know that? Well, notice this. If I plug in 1, okay, that's going to be 1 cubed minus 1 minus 1, and if I've done my math right, that's negative 1, which is below 0. If I plug in 2, I get 2 cubed minus 2 minus 1, which if I've done my math right, let's see, that's 8 minus 3 is 5, and that's greater than 0. Okay, so even if I don't know what this graph looks like, here's what I do know. I do know that at 1, I'm down here somewhere, I'm at negative 1, and at 2, I'm up here at 5. And this thing is continuous. Remember, intermediate value theorem says that for any n between f of a and f of b, so here I'm going to let my n be 0. 0 is definitely between those 2 points. I should be able to find a function value that hits that, right? Because however I want to draw my continuous function, even though I don't want to cross that 0 line, Eventually I'll have to because it's continuous. So this doesn't mean I found the solution, but the question asks, is there a solution? And we would answer, yes, there is a solution. Somewhere between at least 1 and somewhere between 1 and 2, there's a solution. Okay, I hope this makes sense. If you have any questions, let me know. I'll be glad to help. And thanks for watching.